Hi, everyone. Welcome back. Welcome back to another episode of Science Pill. My name is Jessica Nunez. I'm the Youth Program Manager at the Newark Museum of Art. And today we're joined by my colleague, Mary Hiller. Today's Science Pill. Hi, Mary. Today's Science Pill is super exciting. One of my favorite topics. We're going to learn a little bit more about fossils and what they have to tell us about the history of our planet. So while we're waiting, a few reminders. So as people are joining in, I just want to let you know that if you have any questions for Mary at any point during the presentation, please use the Q&A function found either at the bottom or at the top of your screens. We're also on Facebook Live. So if you have a question, type it in the comment area, all right? Now, while we wait for people to join, I want to tell you a little bit about my favorite dinosaurs, Stegosaurus, and I'm going to mess it up. Is it Brachiosaurus?
Yes, Brachiosaurus, yeah.
So I'm a big fan of plant eaters, and I'm really excited to find out a little bit more about them today as well.
All right, cool.
While we were waiting earlier this morning, I was looking up to see if dinosaurs can correlate with your personality. There's so many quizzes on what your favorite dinosaur has to say about you, which I thought was pretty fun.
Did you figure out which one you were?
I got Stegosaurus, but the stuff that it was saying was really bizarre. So I was like, oh, maybe that has nothing to do with my personality. But I thought it was pretty cool. And I'm a big fan of all the dinosaurs with either like plates on their head or on their backs.
Yeah, I am too. Ankylosaurus is one of my favorite ones. The one that looks like the turtle that has all the spikes on its back and then the big popular club. Yeah.
That one actually came up as like everyone's favorite dinosaur. Like,
well, that's surprising.
I honestly thought it would be Tyrannosaurus Rex.
Yeah, well, I know a few people who that's their favorite dinosaur because it's at the top of the food chain. So that would not surprise me if that would be one of the top ones people would choose too.
All right.
All right.
All right. So go ahead, Mary, take it away.
All right. Thank you, Jessica. All right, Stephen, if you could bring up the PowerPoint for me, we can go ahead and get started learning about our fantastic fossils today. There we go. So we are going to be discovering a little bit more about not just dinosaur fossils, but fossils that cover the entire history of the Earth. So prehistoric life we're going to be fosing on today. So we will talk some about dinosaurs, but we're going to focus more on all the different types of life that existed at different times. So let's go to our first slide and talk a little bit about what a fossil actually is. So we're going beyond just talking about dinosaur fossils. We're talking about fossils in general. So a fossil, when we talk about what it is, it's the remains of a plant or animal that lived a long time ago. So you can have fossils of dinosaurs, you can have fossils of mastodons and mammoths, you can have fossils of sea creatures, and you can have fossils of plants. Everything that was alive at one point could have the opportunity to turn into a fossil as long as it's preserved properly. Let's learn more about what a fossil is. Let's go to our next slide. They can also be imprints made by plants or animals. So if you find a leaf that makes an imprint in mud, that imprint in the mud eventually could form into a fossil if the conditions are right. You can also have footprints left behind by animals. So our ancient dinosaurs and ancient mammals that lived long before we did, we find their footprints that are left in the rock because the conditions were right for those footprints to be preserved. So they left those footprints in that soft ground and it eventually turned into rock. So, but what can fossils tell us? Let's go to our next one, our next point about what fossils are. They actually give us clues to the past, to Earth's past, not just our own past, but the past of all living things on our planet. And they are important to the study of paleontology. And paleontology is the science and the study of prehistoric life. So not just dinosaurs, but all kinds of life that lived on this Earth. So let's learn about how fossils actually form. So we understand that fossils are the remnants of life that used to exist. So whether it's plant or animal based. Normally, the fossils, when we think of them, we tend to think of the bones or shells and the hard parts of living things that were left behind and were changed into rock. But fossils, again, can also be those imprint fossils too. So we usually get fossils from the hard parts of living things like shells or bones, or from footprints left in the soil. After time, we're going to go to our next step. After time, we have layers of earth that are going to build up on top of the remains of those living things. And you have things that can pile up on top. You can have dirt, you can have plant matter, you can have other animals that pass away too, that pile on top. And you have all this pressure pushing down on top of those shells or bones that eventually are going to fossilize. Let's go to our third step. So over a long period of time, these layers that are sandwiching those bones in place are going to turn into rock, and the bones themselves turn into rock as well. So this is why we're able to find fossils in different areas of the US and in different areas of the world in different layers of rock, because it tells us more about when those animals lived and how they lived, and also a little bit about how they died too. So fossils are really interesting because it gives us a window into the Earth's past and into life's past. So let's learn a bit more about where we can find these fossils and their ages. So how old is a fossil? Sometimes people might question how old a fossil is, because how could you possibly know how old that fossil is? One way that we can tell how old a fossil is what layer of rock do we find it in? That tells us a little bit more about when that animal might have lived. So imagine the ground beneath your feet is like a stack of pancakes, really thick pancakes. Each pancake is going to represent a period of time in Earth's history. So each rock layer represents a certain time. Certain things happen in those rock layers, and we can learn more about what happened by examining the rock and what we find inside. So what's inside of that pancake can give us clues to what lived at that time and what was going on. So looking at this image here, I want you to go ahead and type into the Q&A section or into our chat section on Facebook, and let me know what you think about the questions I'm going to ask about our image here. So in the image here, we have our purple as our bottom layer. Then we have a green layer, we have a red layer, we have a yellow one, and we have blue on the very top. So which layer do you think might represent the oldest layer? Is it going to be purple, green, red, yellow, or blue? What do you think? Go ahead and type into the Q&A. Okay, we got some people saying purple. You're absolutely right. Since it's the bottom layer, it's going to be the oldest layer. Which layer do you think is going to be the youngest layer? Is it going to be green, red, yellow, or blue? Which one's going to be the youngest one? Okay, we have one answer for blue. Anybody else? Let's give people just a minute to type in their answers. Okay, good. And you are right. The blue is the youngest layer because it's found on top. Now, you'll notice that I have symbols in the different layers. You see some yellow stars, some black X's, we see some purple diamonds, some four-pointed blue stars, and then some orange-colored arrows. If those symbols represent different fossils that we find at different layers, which symbol do you think represents the oldest fossil? Would it be the yellow star, the black X, the blue star, the purple diamond, or the orange arrow? Which one do you think would represent the oldest fossil? Go ahead and type that into the Q&A or into the chat section on our Facebook Live. All right, so you're right. The yellow stars are our, there we go. The yellow stars are our oldest fossils because they're found very, very far beneath the surface. So these different symbols could represent different animals and plants that existed at different times in Earth's history. Do you see any layers where the symbols are sharing a layer? Do you see anywhere where you might have an X and a diamond, or a arrow and one of the purple diamonds? Do you see any layers that are sharing a space? Okay, good, good, good. So We see, like in our green layer, we see our black X's and we see some of our yellow stars. That means that those two life forms lived at the same time. We go up to our red layer, we see that our purple diamonds and our blue 4-point stars are found in the same layer, so they lived at about the same time as well. So where we find the fossils can give us a clue about what different life lived at that time and what life may have coexisted at that same time too. So knowing where we're finding the fossils in the rock gives us an indication of when that fossil was formed, when those animals lived, and who might have cohabitated with whom. Okay, so let's forward ourselves here. We're going to talk about 4 different periods of the Earth's history. And the reason we're going to do this is it kind of goes back to the picture that we just saw. The different layers represent different periods of the Earth's history. So we have 4 different periods we're going to talk about today. We have the Precambrian, we have the Paleozoic, the Mesozoic, and the Cenozoic. Those are the 4 periods we're going to talk about. And that spans the entire lifetime of the Earth. So the Precambrian Era, which is from the beginning of the Earth, 4.5 billion years ago, to about 540 million years ago, if you imagine that on a football field, that period of Earth's history would go all the way from the goal line on our left-hand side all the way to the 12-yard line on the right-hand side. So most of a football field, if we put the entire history of the Earth on a football field, most of it would be taken up by this Precambrian era. The symbols you see on our football field here, we have some rocks, we have some bacteria, and we have a shell. A lot of things happened during that period of time, but not much happened when we talk about life and how it adapted to the environment. Our first rocks that we have a record of that we can date all the way back end up being about 4.2 billion years old. So they would be found at about the 15-yard line from our beginning point on one of the goal ends. To go to some of the first life that we found, which was actually bacterial life, we have basically the first bacteria that the fossils we find for them are about 3.5 billion years old, which would put them at about the 24-yard line. But then you notice there's nothing between that 24-yard line and all the way down to about the 12-yard line at the other end of the field. So not a lot was happening in this period of time when we talk about how life can adapt to its surroundings. Most of the life at this point was bacterial, microbial, very, very small. They were very prolific, which means they were in a lot of different spaces and they were living and they were recreating themselves and they were building up different layers of themselves too. But we have to go almost all the way down the entire field to about the 12-yard line before we start seeing the first of our shelled fossils. So things like the ancestors of today's mussels and clams, that's when they would first start. Okay, so let's go to our next slide, because unfortunately the rest of the period of the Earth's history cannot fit into that tiny little area that's left over on the right-hand side. So we're going to sort of zoom in and we're going to take a look at a chunk of that remaining portion. So remember, we stopped with the Precambrian period at about the 12-yard line. That's when our Paleozoic era started. And this was the age of fish and marine life. So a lot of aquatic life. So different types of fish, ancestors of sharks, ancestors of whales, all these kind of animals started showing up at this point. So we have our fish, our oldest fish fossils we can find are on about the 11-yard line, which is about, if I remember correctly, that's like 425 million years ago, 425 million years ago. On our 9-yard line, the first plants that we found on the surface of the Earth, not underwater, because underwater we had a lot of plants at this point, but on the surface of the Earth, the first plants found on the surface showed up around the 9-yard line. The amphibians, so the ancestors of today's frogs, would show up about the 8-yard line. And the first reptiles showed up at the 7-yard line. So the ancestors to the dinosaurs, the ancestors to the crocodiles and the alligators that we have today, they showed up on the 7-yard line. So very, very short period of time compared to that Precambrian period. So Precambrian period took up most of the Earth's life so far. And all of this explosion of life, all of this evolution of life and these changing animals and how they're adapting to their surroundings all happened in a relatively short amount of time compared to the entire life of our planet. So our Paleozoic era, again, we're talking about massive amounts of marine life, massive amounts of life in the ocean, but not a huge amount on the land yet. But as we transfer from our Paleozoic to our Mesozoic era people tend to refer to as the age of the dinosaurs, because that's when animals started being more populated around the surface of the earth. So we're having more animals who are being found on the surface of the earth, walking around, hunting and gathering for themselves. So the dinosaurs started showing up about the 5-yard line. The first mammals, not like our ancestors, not human ancestors, but the first mammals, which were actually very small, like the size of a mouse to about the size of a badger, started showing up at about the 4-yard line. And the first feathered animals started showing up about the 3-yard line. So this is between 252 and 65 million years ago. The Jurassic period is actually inside of the Mesozoic era. So Jurassic, Triassic, and Cretaceous, that's all contained within the Mesozoic era. That's where the Jurassic period is. So Jurassic has some of the dinosaurs in it, but there were other dinosaurs and other animals in some of the other periods that are inside of the Mesozoic era. But what happened 65 million years ago? Why do you think I say dinosaurs go extinct? What happened on our planet 65 million years ago? Go ahead and type it into the chat. What happened at that point? Meteor. Yep. A meteor or a large comet came in from outer space, scientists believe, and smashed into the surface of the earth and caused global catastrophe. But scientists have actually discovered that there was already the beginnings of certain climate changes that were occurring at that time too. So it wasn't just one thing that caused the extinction of the dinosaurs, it was sort of a domino effect. A lot of people believe in that meteor strike. And yes, we have proof that there was a big meteor strike that hit at that time, but that may have not been the only thing that led to the extinction of the dinosaurs. It certainly did help. But scientists have found information in the rock structure and in the rock strata that there were environmental changes going on, because the earth has had ice ages before, and that is an environmental change. So the earth goes through all these natural changes. We're not talking about global warming right now, but the earth goes through all these different types of natural changes throughout its history. And so there were some climate changes that were going on at that time. And if you don't adapt, you're going to pass away. So that meteor strike helped to sort of push forward that big extinction event. So, and actually scientists believe it wasn't just one meteor strike. There may have been a second one. The first one they believe hit down in the Yucatan Peninsula. The second one they think hit over in India about maybe 200,000 years after. And so there could have been another impact that also caused a continuation of this global change. So let's go one more slide over and talk about the current period that we are in. We are in the Cenozoic era right now. This starts at 65 million years ago with the extinction of the dinosaurs and goes all the way to today. So this is normally referred to as the age of mammals. So hot-blooded animals that give live birth rather than dinosaurs who gave birth using eggs. Even though we still do have dinosaur children's alive today, because we see cousins of dinosaurs still wandering around in bird form now. But here we see, I don't have much going on between dinosaurs go extinct and when the first humans arrive or were found, the first fossils for humans have arrived. But just to give you an idea of how long we've been around compared to how long the earth has been around, when you find the first fossils we found of humans, it's only 1.5 inches away from the goal line on the completely other side of our football field from where we started at the formation of the earth. So humans have actually not been around for that long. We've not been around for as long as the dinosaurs have been yet. So it's amazing to think about how all this different life and all these different fossils we're finding, most of them are within the past less than 1 million years. So it's really amazing to see how dynamic the earth is and how life changes so much as we go from period to period. Oh, yep, tsunamis, volcanoes, and eruptions too are some other things that can cause those catastrophic events that can make different species go extinct. All right, so what I'm going to do now is I'm going to show you some images of some fossils from these 4 periods. And I want to ask you some questions about it. And again, go ahead and type your answers into the chat. So in the Precambrian period, again, that was that period going from the formation of the Earth to about 540-ish million years ago. So again, a lot of bacterial growth, a lot of single-celled organisms going around. Here we are seeing a fossil of what's called a stromatolite. And a stromatolite is a fossilized form of cyanobacteria. And cyanobacteria is some of the first forms of life that we were able to discover through the fossil records that existed almost 3.5 billion years ago. So what these bacteria do is they actually use the sunlight the same way that plants today use sunlight to create energy for them to grow. And so they would layer themselves one on top of the other. So one layer of bacteria going on top of the other, on top of the other, on top of the other, building up these what we call stromatolites. So if you look at the picture where the pointy end of the hammer is pointing, can you see the layers in there? Those layers represent many layers and many layers of bacteria and many layers of life forms that existed about 3.5 billion years ago. Now, these specifically are found in Western Australia in an area called Marble Bar, but there are actually stromatolites that are alive today off the coast of Australia. So that cyanobacteria that was living 3.5 billion years ago, its progeny still exists today. And that's pretty amazing to think that that kind of life could exist throughout all the changes that we've seen in our planet. Yeah, it is very cool. So we're going to go forward from our Precambrian. Remember, there was that huge period where basically it was just bacteria. And at the very end of it, we started seeing our first shelled fossils, so our first bivalves. So if we go to our Paleozoic era, I've mentioned that this was the age of a lot of marine life. What type of fossils do you see here? Go ahead and type into the chat. What kind of fossils do you think these represent? What animals today are the progeny or the children and children and children and children of these animals? Yes, they are fish. So this picture was taken at the Fossil Butte National Monument in Wyoming, here in the United States. It's an amazing national park. So when everything calms down and we feel comfortable in traveling, perhaps you might want to go and make a trip with your family out to Wyoming to see some of the fossils in the rock bed that's out there. This was not actually underwater when it was unearthed, when it was discovered. It was actually fairly high on a plateau, which shows us that not only does our Earth build up layers on top of these fossils, the Earth itself can actually push itself up to create mountains. And so many fossils you can actually find in mountainsides now, even though that land originally was underwater at one point. How many fish do you see here? Or how many fish fossils do you see here? Okay, someone sees 2. Anyone else want to answer? Someone says 3, 2. All right, so there are 2 very obvious ones. There's one that's at the very sort of top. Well, if I have to figure out how you're seeing me here, the very top and a little bit to the right. You have one long one there. You have a big one that's down to the lower left, but there's a third one that's kind of sticking out, coming towards you. That's just below that one on the top. So there's actually 3 fish fossils here. And these, again, are from the Paleozoic era. So we're talking, 425 million years ago that we had the ancestors of today's fish swimming around in the oceans. Let's go forward again in time from our Paleozoic era now to the Mesozoic era. Again, this is the age of the dinosaurs. So not just Jurassic, but Triassic and Cretaceous as well. So we're talking about, we're kind of glumming all the dinosaurs all together in one big era. And we can separate that into different sections if we want to talk about specific dinosaurs. All right, so the Mesozoic era in general is the age of the dinosaurs. And this was a period where you had some of the biggest land mammals, or not land mammals, but land animals that we have ever seen. Is that the pterosaurus? I do not believe it's a pterosaurus. I believe that this was a land animal, because in the very center of the picture, you can see a little bit of the animal's spine, but the legs definitely kind of give it away that it was not a pterosaur. These are very, very large, thick bones for the leg bones that you're seeing here. And I actually see some ribs in here as well. They didn't specify on the website for the National Dinosaur Monument specifically what dinosaur these pieces came from, but this is a picture from the Wall of Bones, which is an amazing basically wall of bones. You have so many different dinosaur bones that are found in this wall. So something happened at this location to cause quite a few of them to pass away all at the same time. And we see some of the bones scattered. We see some of the bones together. So that means that there may have been things that were happening not only with nature, there may have been other animals coming in to scavenge and scattering the bones here and there too. But this is a picture from the Dinosaur National Monument in Colorado. So Colorado being right below Wyoming, you take a family trip, maybe hit both places up over the course of a couple weeks and really get into exploring sort of the history of even some of the states in our own US and some of the different dinosaurs that roamed around at these periods of time. Aren't there wing bones on the top left corner? Oh, I see what you mean. It kind of looks like feathers coming down from the top left corner. I think that might be from where they cut something away, or that's something that's just outside of our field of view. So I can't identify specifically what that is up there. But I believe that it kind of does look a little bit like feathers, but feathers themselves would not fossilize very well. The imprints of them might, but the feathers themselves would not fossilize very well. Okay, and our last period, let's go to our Cenozoic, which is again the period that we are in. And we tend to think about ourselves, but also the Cenozoic includes a lot of different mammals. So like mastodons and mammoths and saber-toothed tigers and giant sloths, all kinds of different amazing mammals that we find at this time. So here is a fossil that was uncovered again in Colorado. Colorado is an amazing place to go to look for fossils. This is the Columbian mammoth at the Ziegler Reservoir site, which they now call the Snow Mastodon site. This was dug up back in, I believe the first one they found was the 1970s or so is when they found the first mammoth fossil. Not necessarily at this site, but so this mammoth fossil is the remains of the animal that you see in the upper left-hand corner. So I want to ask you a question. Yeah, they are really big tusks. I want to ask you a question. What animal that's alive today do you think might be a relative of the mammoth? Elephant, absolutely, yep. So today we see the relatives of these prehistoric animals that, well, some mammoths were around at the time of our ancestors too, very, very many years ago. But like when we talk about dinosaurs and stuff like this, we see a lot of different information about animals that lived in different periods of time. But with these mammoths, it's amazing to see just how long the tusks are and that they're a little bit bigger than today's elephants. So our elephants today aren't quite as big as the mammoths and mastodons, but we see a lot of similarities between mammoths and elephants now, especially with their teeth. So that gives you an idea of just some of the fossils that we can find at these different periods of Earth's history. So let's go one more forward past our Cenozoic, since we are now today, because we've gone from the beginning of the Earth 4.5 billion years ago all the way up to today. Today's activity, we are going to be making fossil imprints of different types of examples of material that may be fossilized. So I'm going to show you how to make the dough that you're going to be using to make these fossil imprints. I went outside and harvested some things from nature that's around where I live. You can use different types of toys that you have in your home to do the imprints, but for our recipe for our dough, we're going to need a 1/2 cup of wet used coffee grounds or bagged black tea leaves, or you can actually use a 1/2 cup of dirt if you have, that's more accessible rather than coffee grounds or black tea leaves. We're going to need a 1/4 cup, of cold coffee or black tea. We're going to need a 1/4 cup of salt, a whole cup of flour. You're going to need some measuring cups to measure your units out. We're going to need a mixing bowl. We're going to need a mixing spoon. It would be good to have a cookie sheet so that you can keep your space clean, but also so that you can have something to dry your fossil imprints on. And then also you want to sort of hunt around your home and hunt around the outside of your home too, if you have the opportunity, to look for things you can do imprints of, like leaves and pine needles, tree bark and other things. Even if you have some plastic dinosaur toys at home, you could leave an imprint of that in there. So what I'm going to do is show you how to make the dough, and I'm going to show you how to do some of these imprints as well. But one final thing I want to do, let's go to our last slide, is remind you, if you want to take pictures of all the cool things that you do at home that are influenced and inspired by these science pills, please go ahead and share those with us. We would love to see them. Again, our hashtags for this is NMOA at home and also NMOA science pill. So please share all the fun that you are having with us in doing these different activities. Okay, so let's go ahead and stop sharing the presentation. And I'm going to go ahead and start showing you how to make this dough. So I am going to be using just a little Tupperware container here as my mixing bowl. You can use something a little bit bigger. This is just easier for me to handle and showing you what I'm doing rather than using one of my really big glass mixing bowls. So this makes it easier for me. I'm going to use a very large serving spoon as my mixing spoon. You could use a wooden spoon. And one thing I want to say is that if you use a wooden spoon, you do not want to use dirt, because you want to make sure if you're using dirt, you want to use something that is not porous and you won't get any bacteria or anything inside of it. Of course, you want to wash everything too. But if you just use coffee grounds or tea grounds, you're perfectly fine using a wooden spoon, but it's up to you what you have available and what you want to use. So what I'm going to do is I'm going to do like I normally do in baking. I'm going to take my dry ingredients, mix them together first, and then add my wet ingredients. So I said that we need a cup of flour. What I did was I took my cup of flour and I split it up into 2 equal parts. So each of these containers has a half a cup of flour in it. I'm going to start by adding 1/2 cup of flour into my container. I'm also going to add my 1/4 cup of salt into my container. So I'm adding all my dry ingredients together first. I'm going to use dirt today for mine, but again, you can use tea leaves. You can use, and make sure that they are used because they'll absorb some water. They'll get a little bit bigger and they will stain the dough a lot better. So I'm going to use some dirt as well. This is a half a cup of dirt, or you can use half a cup of tea leaves. I do have some leftover tea leaves as well here. So this is about 1/4 cup. So I'm just going to go ahead and add that in anyway, because I would like my stuff to look, you know, almost like soil. So that's all of my dry ingredients for now. I still reserved, whoops, that 1/4, or not 1/4, 1/2 cup of flour, because we're going to need this when we're mixing our dough together and our dough is still a little too wet. We're going to be adding this flour in as needed. So you are going to mix all your dry ingredients together like so. Once you get them really well mixed, you're going to go ahead and add in your 1/4 cup of either coffee or black tea. I'm going to open up my jar here. I'm going to pour that in just like so. And then you're going to continue to mix. Now it is going to be very wet as you go here. That's why we reserved that extra 1/2 cup of flour, because we don't want to add all the flour in at once because it might make it too dry. So I'm mixing this in. You can see how nice and dark that's turning there, because I had not only the tea leaves, but also the mud, not mud, but the dirt as well. But you see, it's not really in the form of a good dough that's going to be easy to mold. So that's why we need to add our last 1/2 cup of flour. I'm not going to add it all at the same time. So we just mix and mix. So eventually, I'm going to do some magic here. Eventually, you're going to get a dough. And this is stuff I pre-made ahead of time. You're going to get a dough that's similar to Play-Doh. Now, with all the salt that we added in there, this is not an edible dough. Okay, this is not something you want to leave around for any pets or young children to get into, because the amount of salt in here is not good for anyone. So it's not something to be eaten. If you want to make tracks with your animals, you want to put your cat's paw in there or your dog's paw, do not do that, because instantly they'll go, ooh, I don't like that. And they're going to start licking their paw. They're going to be ingesting a lot of salt from that. And we want to keep our pets safe. So do not use your pet's paws to make imprints. One way you can make an imprint is, if you want to do some different footprints, I'm going to take a smaller piece here, and you want to flatten out your dough so that it's about maybe 1/4 of an inch thick, 1/4 of a half. I wouldn't say any thicker than a half. I wouldn't say any thinner than 1/4 of an inch because you do want it to have some stability. I'm going to use a toothpick, as you can see right there. And what I'm going to do is I'm going to go ahead and press the toothpick in to make little feet, like so. So you can actually create your own dinosaur footprint tracks in your fossil dough. Now, if you want to keep these, you're going to let them sit for probably, I'd say, at least 2 days for them to harden. If you want to use them as decoration, you want to hang them, you can take your toothpick and you can create a hole with a little bit of space between the edge of your dough and where that hole starts so that you have something to loop through with your yarn or string, and you can actually hang it. Another thing you can do with these is you can have somebody hide them or bury them outside for you, so you can actually have a fossil dig outside. Or if you don't want to do it outside, you could take a toy box or some other type of box where you would fill it with different toys and put these at different layers, so you can discover your fossils in that way too. So our footprint is one way of making that fossil imprint. I harvested a couple different things from nature around where I live that we can also use to make imprints. So I have a pine cone. I have a couple different leaves here that we can use as well. I have a few seeds from trees right there. I also have some tree bark that I can use. And one of my favorite ones, because this works so well, I have some pine needles. Now, I did not peel these off of trees or anything. I went around and I found what had already fallen down on the ground. So I encourage you to take some time to go out into nature to see what you can find, and that you're not taking it off of plants. Make sure that it is something the plant has already given up. So basically all you need to do is just take your dough and again, flatten it out. You don't have to flatten it out in your hand. You could flatten it out on top of your cookie sheet if you wanted to. And then that way it's already there to dry. But let's do the pine needles. So what I'm going to do is I'm going to place the pine needles on top just like that. And I'm going to press. And when you press, you're actually representing the forces that the fossils went under as they were being formed into fossils. So those bones or those plant matter were being compressed by layers stacking on top of them. And eventually the plant matter goes away. It doesn't get peeled off, but it goes away. And you're left with a fossil imprint. Trying to turn my hand enough to where you can see that. So you can see all the little lines in there. So you can see how you can make an imprint with a plant as well. So this gives you an idea of some of the different things that you can do in making these imprints. And now again, remember, if you want to have fun, get a family member to hide them for you so that you can go on your own paleontological dig to see what fossils you can discover. Make sure that they remember where they hid them, because if you don't find all of them, you want to make sure you get all your pre-made fossils back. All right, so that gives you an idea of how you can actually make your own fossil imprints. So let's go ahead and let's take some questions from our question and answer section and also from our Facebook Live.
All right, Mary, thank you so much for that presentation and making these amazing fossils. Before we get the questions, a lot of our viewers are interested in that recipe. Stephen, is there any way that we can pull that back up for a few seconds so people can take a screenshot?
Oh, absolutely.
All right, everyone, as we get that recipe back up on the screen for you, feel free again to use the Q&A function inside Zoom or the comment section on Facebook to send us your question. So there it is up on our screen. Feel free to take a screenshot. We'll keep it up there for a few more minutes while we get these questions trickling in. All right, let's keep it there for a second. Mary, the very
Mhm.
first question came right at the beginning. Someone wanted to know, what does Precambrian mean?
Okay, Precambrian, excuse me. Precambrian basically means before the Cambrian period. So the Cambrian period is the first section of the, oh gosh, now I'm going to forget the name of it. Hold on. The Precambrian is the first section of the Paleozoic Era. So we have different sections inside of those four main time periods I talked about today. Precambrian basically means everything that came before when we started seeing, everything that came before we, how can I say this? Everything that came before the first fish, the first bivalves. So it's basically the entire history of the Earth before we started seeing a lot of recognizable animals and plants that were appearing in the oceans and on land. That's what Precambrian means.
All
So it's
right.
basically referring to the earliest time periods of the Earth's history.
Okay, someone wanted to know a tiny bit more about the Jurassic period. I remember you saying it's one of the periods inside the Mesozoic era, correct?
Correct, yeah. Yeah, so with the Mesozoic era, you have the Triassic, the Jurassic, and the Cretaceous. So if we want to break that down, let's see, Mesozoic. So when we think about the Mesozoic era, we're talking about the animals you would have seen like in Jurassic Park, but also combined with animals that you would have seen in the Triassic and the Cretaceous. So we're talking about all dinosaurs in that period. It isn't, when we talk about dinosaurs, they just weren't around in the Jurassic period. They were around in the Triassic and the Cretaceous too. So instead of focusing on one small time frame, today we wanted to focus on the bigger time chunks. And we can, if we had time, we could go into more detail about each specific period within these eras. But unfortunately, we don't have the time to do that. But basically, the Jurassic period is one of the three that's found inside of the Mesozoic era. And with the Jurassic, that's where you would find like some of your larger dinosaurs, your Tyrannosaurus Rex, your Gigantosauruses, your Argentinosauruses, some of our favorite ones too, you would find within that Mesozoic era, but some of them specifically within the Jurassic period.
Mary, I know that we talked a little bit about how sometimes it's difficult to express time because it's a little bit abstract.
Right.
A few of our viewers want to know either how long is a time period or how long is an era. Are there defining factors to where one era stops and another one begins?
With our Earth's history, yeah, there are defining factors as to where one era stops and one begins. But the eras themselves, it's not like, okay, an era specifically is 300 million years or something like that. It's built more on some of the biggest changes we see happening between one period and another. So like with the first dinosaur fossils that we found, you know, that we can date them all the way back to that period, that would be one of our spaces where we define one period from the other because we saw such a change in the life that was on the Earth. So an era is not a specific length of time, like a year or a decade. It's more of just a, it's a framework to build in where different changes occurred in the Earth's history rather than specific times themselves.
Okay. Let me see here. I know we're running out of time, but I do have a few other maybe quick questions. Is it true that scientists have found a frozen baby mammoth?
I heard something about that a couple of years ago. Yeah, we have found evidence of mammoths that are frozen in ice because they were around at the time of the Ice Age. So even though some of the science in the Ice Age movies with Manny the Mastodon and all other are for the favorite characters, some of the science might not be as accurate in there as what maybe actually happened to these animals. We do have discovered animals that are kind of frozen in ice, and I believe in some cases we've actually found like spear points or spears actually sticking into the animal too, which showed that people were around hunting them at that same time.
That's pretty wild. Keeping in the same tone with movies, someone wants to know, was Jurassic Park named after the Jurassic period?
Yes, absolutely. That's why they have the big Tyrannosaurus Rex skull as part of the symbol for it too. Yeah, yep. It was they absolutely took off of that. Although some of the science that they do in there is a little Questionable because not sure if you can
we can't clone a dinosaur.
Nah, not with our technology. No, unfortunately. And you know what? You wouldn't want to, because the environment that they lived in is much different than the one we lived in. There was more oxygen in the atmosphere when they were alive than what we breathe now. So they could actually suffocate if they were alive today. So we do not want to do that to any animals, no matter how cool we think they are. So
it's true. Someone just wants to clarify, when making the fossil, you can use dirt instead of using the wet coffee ground.
Oh, absolutely. The only thing that I want to specify about that is that if you are going to use dirt, since you don't know what sort of contaminants might be in the dirt, make sure you're using stuff that you are then going to throw away after mixing it together. And to store the dough, you can easily store it in a plastic bag. And if you don't make all the fossils with all the dough and you want to store the dough, you can store it in a plastic bag for probably about 2 weeks. You do want to take it out a few times just so that it doesn't get too wet or moist inside of the bag, so that you don't have bacteria growing. But with the amount of salt we put into it, more than likely bacteria is not going to grow.
All right. Last 3 questions. Is it true that there's a place in New England with dinosaur footprints?
I would imagine that there are. Actually, New Jersey is one of the best places, even though we're not literally in New England, but New Jersey is one of the best places to go when you're looking for aquatic and sea fossils. There is actually a fossil dig site that is down in South Jersey that's being run by the Rowan University down there. They are working on building their own sort of mini dinosaur museum down there, but that's not going to happen for a couple of years. They actually do have public open days, but they take reservations. It's not like free and open to the public where you can just go anytime. You have to fill out a form, you have to reserve your time, and you have that one time to come down and look for fossils. They'll actually let you dig there too. It's an amazing site to go to. So even here in New Jersey, you can go out to specific locations and actually dig for your own fossils.
All right. Who introduced the study of paleontology and fossils, Mary?
That's a good question. That one I don't know. So let's see if I can quickly do here. Oops. Who was the first paleontologist?
As Mary's looking that question up, I do want to remind you that the Newark Museum of Art, we have a huge science collection. And in our exhibition called Dynamic Earth, we do have a variety of fossils that touch upon all the periods that Mary talked about. Did it come up?
So there are 2 people who are credited with being the father of paleontology. So one is Georges Cuvier, and the other one is William Smith. I'm not sure where Georges Cuvier is from, but William Smith was from England. They don't say specifically here where Georges Cuvier was, but with the name, possibly France.
We're going to leave you with that, and that'll be your homework assignment, everyone.
Okay, there you go.
Next time we're in Scienceville, you can leave a comment below and clue us in. So again, thank you so much to everyone who joined us today. I do have a few reminders before we go. Make sure you join us for Museum Crawl tomorrow. Tomorrow is Wednesday, right? Tomorrow, yes. Wednesday at noon, as well as story time with outrageous pets. And we will have a very special pet. I think it's a sloth, but I'm really excited to see that. That's at 3 p.m. And then on Friday, we have this amazing poetry pop-up inspired by our exhibition with Norman Bloom. And we'll have several improv artists and poets engaging with the public. And that'll be Friday at 7 p.m. And then the biggest news of all, though, has to be Science Week, the week of June 15th. So a whole week devoted to science. We'll have many of these live sessions and a lot of other activities going on. But again, thank you so much, everyone, for joining us. Thank you so much, Mary, for all that awesome information.
You are very welcome.
Bye, Mary.
All right, bye, everybody.